So today's lesson, can you hear me?
Yes.
Yes. Today's lesson will be going about the index law and the logarithmic law plus the applications of it. So let's see. I'm going to screen share. Sorry about taking a little bit time. I'm making this so that you can study again at home, yeah? Nicholas?
Okay.
Yeah, so that you can review again at home. I'm going to start sharing the screen. Start now. Alright. Can you see my screen now?
Yes.
Yes, you can. Right. I'm going to make it a little bigger. Can I make it bigger? Can I make it bigger? No, I cannot. That's the best thing that I can do. Okay, never mind. Last time we have done the exercise with the index law. Several problems like number 5, we know how to have the rational numbers as the power, as the indices. For instance, if we have x to the power of 3, 4, means you have the fourth root, but then the x is raised to power 3. Alright? Now, what about x to the power of 9 over 8? Meaning you have x to the power of 9, x to the power of 9, and the 8th root of the power of 9. Alright, the next example is about this one, checking whether the two are equivalent or not. Checking it, whether it is equivalent or not. Can you hear me, brother?
Yes.
Yes, alright. And then the next one is this one. We have to simplify it with using the index notations. The first C questions, this is too big. The first C questions will be x to the power of 6 over 7. Have we discussed that?
Yes.
Yes. And this one too, even though the 9 is outside the bracket, you usually can do this. X to the power of 9, and this is the 8th root. So basically x to the power of 9 over 8. Same thing like this one. This is actually 1 over x to the power of 2 over 5. And then you can flip the x up. You bring it up as the numerator. And then you get x to the power of 2 over 5. Alright? And the last one with h, I think we have done until problem h. Am I right?
Yes.
16 over 6. Alright. What about now problem I? We are going to discuss that. Problem I. Problem I hope if there is a problem with the voice, with the internet connections, just tell me freely, yes?
Okay.
So let's do one by one. This reminds me of another law that says if I have a power x, or no, power m usually we have, power m, and then raised again to power n, it is just a to the power of the product m and n. So this is only the power index here and the indices here. The two will be multiplied. So it will have x to the power of 3 over 4 times 1 over 2. Multiplied by Next one, y to the power of negative 1/3 multiplied by 1/2. So the answer will be x to the power of 3/8 times y to the power of negative 1/6. You get the same? Hopefully. Have you tried? You done? Pardon? Okay, you're still doing it. So I gave you the example of I. Can you do it now? J and L. J and L. Okay. Can you try it? J and L. Alright. Now let's discuss. For the problem of J, I can write it like 16 xy to the power of negative 5/6 to the power of 3, and then all thing will be raised to power 1/4. So meaning I have 16. 16 can be written as 2 to the power of 4. 2 to the power of 4 is 16. X to the power of 1. Y to the power of negative 5/6. In bracket, to the power of 3 and 4 can be multiplied. They are all together becomes 3/4 as a power. 3/4 as a power. Now, yes. So, yeah? Well, the first one is from here inside the bracket, and then the next one is here, so 3, 4. Basically 3, 4. If you have like an x to the power of 3 and 4/3 of it is basically x to the power of 3/4. Understand?
Yes.
Yes, this one combined together becomes 3/4. Now, let me erase this first. Everything clear, yeah, brother? Is it clearly seen? Yeah. There is no lagging?
Yes.
That's good. Okay. Now, we multiply each one of them. The 4 with this one, the 1 with this one, and finally the 5/6 with this one. Oh, you cannot see it anymore. Okay. Let's do. You have 2, oops. You have 2 to the power of 4 multiplied with 3 over 4 times x to the power of 1 times 3 over 4 times y to the power of 5 over 6 times 3 over 4. So what do you get then? This means you have 2 to the power of 3. It is just an 8. 2 times 2 times 2 means 2 to the power of 8. And then we have x to the power of 3 4. And then y to the power of, let me see, can you simplify this? 3 and 6 cancels. So you have only 2 on the bottom. 2 times 4 is 8, so minus 5 over 8. That's it. Is it clear, brother?
Yes.
Yes. If you finish with L, then I can discuss it. Are you finished with L?
No, sir.
No, sir. Okay. Can you do it now?
Sir, I'm done.
Yeah, you're done. Okay, let's do it. First of all, I'm going to bring this up, so it will be, yes? Oh, yes. Sorry. First of all, I'm going to bring it up, or maybe I will say I will not bring it up. I just leave it first as the denominator. So this will be x to the power of negative 7 over 2 times y 4 over 3 close bracket to the power of 1 over 9. Correct? Root index means rational number, so 1 over 9. If you have, then this move up, then you will have x to the power of negative 7 over 2 times negative 1 over 9. Because you move up, this becomes negative. And then you have y to the power of 4 over 3 times negative 1 over 9. This is the same like x to the power of positive 7 over 14 times y to the power of negative 4 over 27. So do you get the same?
Yes.
Yes. Now, after this, we will move to the exponential equations. This is no longer algebraic manipulations using simplifying or changing the form, but rather we want to solve it, to solve equations. But still, there's one more thing, to simplify things using the index notations. Especially if we have the plus and minus like this, or divisions even like this. So what does it mean? This reminds us of a to the power of n, the first question a, times a to the power of n, just the same base will be multiplied with the sum. Okay, I will not do all, just a little review very fast. I just pick and choose several numbers for you.
Sir.
Yes?
Sorry, sir, but for L, I think we have to.
Oh, okay. Let me check. 7 over 2, 4 over 3. And then we move up, it becomes negative and negative. Negative times negative will be positive. Oh yeah, here, I make mistake. 2 times 9 is not 14, but 2 times 9 is 18, correct?
Yes.
And then negative 4 over 27, do you have the same?
Yes.
Alright, okay. Now, I just pick and choose. Please do this D, F, H, and J. So the 4 questions here, please do it. Okay?
Yes.
Yes. D, F, H, J. D, F, H, J.